So this talk is going to be speculative. It's what I think the future of coding will be in the age of AI. Spoiler, it's not related to Python, but there's a lot of inspiration that comes from the Python world. So this is more a kind of an information sharing from the Haskell world. So I think anyone's used generative AI to write code in any serious fashion. And as that happens, I think there's an effect where the more code you have, the more your productivity is hampered not by the amount of code you can write, but by the amount of correct code you can write, or rather, how much you can check the code. So, you need a lot more senior engineers to be able to check random errors, to make sure that code is unit tested, code is compiled well, or code validates in general. And you can see this in loosely typed languages. Sometimes, like Python, you get a lot of these errors where it's like if you multiply a by 3, and someone at some stage put like a string in there, it'll end up with a bunch of 4s instead of 44, and a lot of those type errors are swallowed. So I'm the author of a data frame library that's based on pandas, but in Haskell. It's called Data Frame, and I joke, my high school principal's dog was named Dog, and we asked him why, and he was like, if I love him, I don't have to give him a name, He knows our relationship is special, you don't need to know anything about that. So I didn't know what to call it, and I took inspiration. It's just called Data Frame, but it does a lot of construction by types. So this is a type error. It never ran the code in the first place. The compiler kind of just caught it. And I think in the era where in 2019, for example, code was the expensive thing, these tools kind of didn't matter as much, and a lot of the software verification field was segmented outside into the academic world. I think in 2025, it's becoming a lot more relevant as we mode collapse into writing a bunch of code. And I'm part of an organization called Data Haskell, where we seek to bring some of these approaches from academics. And we've taken a lot of inspiration, like I said, from the Polars community, from pandas, and also from Julia, I think, to be able to create tools that MCP servers can run and compile code in the back without ever having to, I guess, run the code. And the types would prove that it's correct. So I think a little demo of what this means. I'm going to put this down for a second. Let's say I have, it's large enough? No. Let's say I have the classic California housing data set. We can run info on it, and you can see that total bedrooms is null or has some null values, and that's encoded in the type. So if I were to, let's say, this creates our symbols that we will use to reference all the code. If I were to, let's start by just selecting. Don't mind the syntax for now. Just trust me, it's all okay. Median house value. And you can see, it's kind of embedded in the type that this thing might fail, and you might see a lot of this from Java's optional or Rust's optional type as well. But let's say you try to derive, which is kind of the same as with columns in Polars, if you're familiar with it. Like change total bedrooms into, let's say, 2 plus total bedrooms. The code doesn't even run. The compiler says, hey, you have this thing that might be null, and you're trying to add a number to it. That's impossible. So now we know to do something like, well, only if it's present. And we get this thing that now is correct without you even running the code and running into a lot of runtime exceptions. So the challenge has been, at least the big inspiration we've taken from the Python community is, how do you make an ergonomic tool that appeals to a lot of people that also is correct? And that's a pretty difficult trade-off to run, but it's one that I think we're trying to challenge. And I think in the spirit of Wittgenstein, there's a quote that says, the limits of my language are the limits of my world. So if you're ever considering learning a new language, be on the lookout for what's happening in the Data Haskell world, and we'll also be on the lookout in what's happening in the Python world. Thank you.
Hi, I'm Bernardo. Yesterday, I gave a talk yesterday I gave a talk and I released a data validation library in Python. It's based on Polars. It's Paguro. Go check it out. And I described the library yesterday, but I want to talk to you now about an extension where I'm taking this library to. And if you have some feedback, I would love to hear from you. So basically, I'm talking about LLMs and structure outputs. You all know what structure outputs is. In most cases, we're talking about JSON outputs. But this JSON often can be put in a table, right? Even like deeply nested JSONs, you can have structs in pollers, and you can represent that in a table. So when with one row, in general, this is the pipeline for like structure output generation. You have like a schema, typically Pydantic schema. You have some prompts, tool calling, then the inference, validation, and you get the application. So what does it look like in Pydantic? For the single row, you define your attributes, your fields, and your constraints. You get you call either tool calling. Nowadays, most like LLMs have most SDKs have like very nice API to call for tool calling. And this is great. But what happens when you have multiple tables, multiple rows in the single table, right? In Pydantic, this becomes a bit more cumbersome if you want to define constraints across fields, or even within fields across rows. You have to start specifying very complex things, because Pydantic wasn't thought about tables. It was thought about like class objects and inheritance. So what can you do in Paguro? And then in turn with this extension, this extension is fully based on Paguro, and Paguro is fully based just on pollers. You define your schema, which is you define your vectors, your columns, and you can set any kind of constraints that you want. Of course, these constraints will map to a JSON schema. So all the JSON schema constraints can be mapped to Polars expressions. The Polars expressions that are not mapped to JSON schema constraints will be just annotated constraints to the LLM. So for example, a unique is going to be just an annotation, but the LLM is going to know, because when you call chat with your schema, you get your output. So you can call chat, extract, or generate, and you get, and I'll show you a little bit what this looks like. So that's an example more. You get your schema, you can extract, you call your model, you say what model you want to use, and you extract data from documents, right? So these are like the documents. These are just 5 documents, but you can extract data just from a schema without. So the easiest way to use it is actually you just provide the column names that you want, you pass the documents, and the output is going to just be a table. Nothing happened more than just defining a schema for the table that you want out of it. Generate looks very similar to it. You basically, after having defined the schema, and this is an example with some more information. I want names. The schema is just a column in this case. A column that's going to be a strings, but you can define what constraints on the strings you want to have. You add information to it. You add names from Star Wars, and you get names from Star Wars. So like you want these names to be unique, and they all start with an L, and you get unique names with an L. Or in this case, I also define an age. Yeah, and behind it, there is the Paguro validation, which is very fast thanks to the Polars query engine. For small schema, it doesn't really matter. For large schemas, it does starts to matter. And you can see how this then kind of fits into a pipeline in which, if you do want to inject that generated table into a database, you already have a validated table that will like comply to your to the schema that you have. Good, thank you very much.
Okay, cool. So I think the keynote speaker, Chung, gave a talk about LanceDB, specifically around file formats and table formats. And throughout, I think, PyData, we've heard about other file formats like Parquet, Iceberg, Hoodie. So I do work on some of these projects. I'm actually a contributor for Hoodie, Iceberg, and I'm a PMC for Xtable, which is this talk. Originally, I worked at AWS, but I left that to join a data startup, which primarily works on Hoodie and Xtable, as well as offering our own kind of Spark-compatible compute engine. So if you're running Databricks or EMR and you want to save money, come talk to me. Cool. But I will not be talking about the company so much as giving an overarching view of why you should actually care about these file formats and table formats, what they actually bring to data users today. And to do that, I think we need to kind of first talk about just the history of data architecture as a whole, what these table formats bring, and then what a kind of Xtable fits in this ecosystem. So if you're someone who is building a data lake or you've used a data lake, it can kind of be like that left image where it results in a lot of tiers. And I find that in this industry, there's so much jargon for like data warehouse, data lake, data mesh. So I feel like we're just kind of confusing people. And I want to give clarity as to what this actually means. So traditionally, up probably from the 70s to the early 2000s, your database management system was a collection of several services tied into a single system. Users typically would take SQL, which would be transpiled into some kind of abstract syntax tree that would then be written through many optimization layers to basically scan the underlying data that resides in the disk of that compute node. And while these systems were very easy to use and very robust, the main thing that became challenging was that you couldn't scale compute and storage independent of one another. In contrast, in the early 2000s, during the internet era, small groups of teams were generating large amounts of data, and they couldn't afford these very big kind of Oracle Teradata type systems. So they would basically take open file formats like text files or Parquet files and just kind of dump them on, at the time, was a distributed file system known as HDFS. And the current architecture pattern today is kind of a mesh of the two. So instead of taking your files, let's just say something like Parquet, which is just some way of representing the serialized bytes of your data, you will basically have that in one of these like Parquet or Avro files, and you'll choose one of these cloud vendors like AWS S3, Google Cloud Storage, ADLS, and you bring one of these compute engines, whether it be a proprietary engine, such as something like a Snowflake or a Google BigQuery, or maybe you're using an open source engine like Apache Spark or Trino. And specifically, these table formats, such as Apache Hoodie, Iceberg, Delta, essentially are bringing just ACID transactions on the data lake. So what I mean by this is when you update a table, you want to have some notion of a commit and basically be an all or nothing operation, or having the ability where you have two writers writing to a table. So you don't want these processes to interfere with one another. So you should have some layer of isolation. And if we were to really just take a step back to understand what these table formats are truly doing, all it really is just metadata files on top of the underlying data files, which are just usually represented in Parquet. So what these metadata files bring is the ability to perform time travel queries. So say I make some updates to my table, let's just say like several days ago, and I want to be able to query the table at that specific instance in time. How do I kind of view those collections of files at that particular point in time? Or say I want to add a new column to the table. So how do I actually evolve my table to change the data types or the schema? So essentially, Hoodie, Iceberg, Delta provide these abstractions or metadata abstractions to basically logically view your Parquet files. So for Iceberg, it's more of like a tree-like structure where you have a list, you have a metadata JSON, and basically it points to a list of manifest files pointing to basically the data files where it tracks what actually got changed or removed. I see someone's probably pointing me out. If you want to learn more about Xtable, it pretty much is just a converter between these formats so you don't get locked into one of these vendors. Thank you. Okay.
All right, ladies and gentlemen, I am Jake Stevens-Haas. I just recently finished at University of Washington, and I maintain our lab's, one of our lab's libraries called PyCindy for the sparse identification of nonlinear dynamics. And rather than going into detail about what that does, I'll have a slide on that. I want to talk about the lessons that I have learned from trying to do my PhD research through not just putting out new repositories or new packages each time I published a paper, but trying to corral a bunch of different researchers and different published methods into the same library. So briefly, the problem set that I face is learning differential equations from data. So you can see here an image in red of the classical Lorentz system. You have an x, a y, a z, and a particle is moving around, and there's some derivative, some rate of change over time, but you might only have some noisy measurements in blue up there. And can you, in fact, discover the equation from the noisy measurements? This can be done for systems like that. It's also used for econometric variables, neuron voltages that might have some connection or interaction in the brain, different chemical species in a metabolic network. And also be used to convert ODE or PDEs into ODEs for fast simulations. And one of the challenges we face, and one of the reasons that I think this problem set is so interesting, is there's a lot of different ways to evaluate these methods. You can look at the functional form if it's some benchmark and you know what you're trying to get out of it. But other times, what matters much more is just the immediate prediction of the derivative if you're trying to inform some sort of a control scheme. If you instead are trying to simulate forward in time, you want perhaps a guarantee that the discovered model won't blow up in finite time, or that it is globally bounded. And so there's lessons from Lyapunov stability. And basically, it all comes down to understanding a system for hundreds of years since Leibniz and Newton meant learning the differential equation. That's the sort of explainable AI, or the explainable ML side of all of the different non-parametric and parametric models. It works. It gives us, there's a lot of things that we learn about from discovering the equation because, as I said, we have several hundred years of tools when we understand a system via differential equations. But I want to, the things that I haven't really understood or solved or have only begun to grapple with during the later years of my PhD is the sort of practical problems of doing research with these open source packages. So our method, PyCindy, has a variety of different innovations that have been supplied by researchers. But if you're doing new research, do you make the pull request and implement the method before you've written the paper? A lot of researchers don't like doing that. A lot of researchers are worried about getting scooped, although I would argue that once you're at the point where you know exactly what you're doing and implementing it, you're far enough along that chance is pretty low, but it's still hard to get people to do that. You could go on your own program, and it's part of the point of having a common repository is that people know where to find some of the research. It helps promote the research as well. People can use it. And then the other sort of leg of this triangle is where you want to do open research, but you kind of want to hold on to it for a while. So you form a branch, and then over the course of a year, as you're coming out with your new method, someone since fixes bugs or refactors or improves the areas of code that you have branched off of, and you have a year's worth of merge conflicts to try to resolve after submitting the paper. No one wants to go through that legwork. What I've found, the only thing that I have found works here is being willing to handle all of those merge conflicts in exchange for becoming a co-author. Second challenge faced is methods researchers, mathematicians like myself, like to talk about and publish methods. And so there's a little bit of a self-licking ice cream cone on the right, whereas this is nominally all for science. And there isn't a great connection to people with data and there also isn't a great connection to people whose methods are branded slightly different. Originally, PyCindy stood for sparse identification of nonlinear dynamics. Sometimes sparsity doesn't really matter. Other times, you're doing a method that isn't really regression-based, but is instead based on some genetic algorithm. Those tend to be grouped under symbolic regression, and I'm getting a notification that I'm almost done. Basically, there needs to be a better forum for exchanging type compatibility, some sort of forum for type compatibility between related problems. And then the last thing I would talk about is how to get scientists to write better mathematical code, and I have some style guide for that as well.
Hi. So this is me, Micheline Harris, and I'm a data scientist. I'm in the area, in Seattle area, and I run a few meetups. I'm happy to be here at PyData, one of the sort of volunteers, organizers. So I'm glad everybody else is here too. Who deals with text de-identification? Like also text and images, like any PII, stuff like that. Yeah, I mean, we nowadays we work with text a lot, right? So yeah, if you imagine you have, I don't know if this is the resolution changed a little bit in sharing, but I asked ChatGPT to make me some clinical, like a basically a doctor visit note, right? And it has stuff like the name of the doctor, the location, like of the clinic, things that are private, definitely PHI, right? Like, so you wouldn't want that going into your training data set necessarily if you're trying to, keep your data private, including image data, right? Like think about radiology scans. They have like identifiers for the patients on them. So you might think about like in your training data set, you should anonymize that text, right? Okay, so an organization that I'm in at Microsoft has this open source project called Presidio. And it has like two parts to it. One part is identifying the PII or PHI, and the other part is anonymizing it. So you can kind of do both. You can throw in different models, use like pre-built ones in Spacey, Stanza, and I think pretty much any Hugging Face model that is compatible with Spacey pipelines. So let me see. Next, I'm just going through tabs on my browser. I hope that's OK. I don't have any slides. But yeah, so this is the docs for Presidio. And it is kind of modular. So as I said, you can kind of break up the process. You just want to identify the text, the PHI or PII. You can use this library or use the named entity recognition models to actually anonymize it. So I was going to show you actually a script that does this momentarily. Basically tokenizes, lemmatizes, and tags it, and then does NER with a Hugging Face transformer. But there's also another sister library for evaluation, because we always have to evaluate our models, including our anonymizer models, right? So this is Presidio-Research, which has a evaluator library. And then there's some labeling tools here, I guess. DS Toolkit labeling app, so you can make those labels to evaluate your NER models. And some of you probably use Docano for labeling text. It's a great tool. Love Docano. It's just like you create this little, I don't know if it's a Flask app or Django app, but it's like a UI, and you can deploy it to the cloud too. And let me switch over. So I took that, sorry, I just prepared this right before this talk, but I took a note that I showed you earlier that I created with ChatGPT, And it was pretty simple to just create this script using the analyzer from Presidio, the anonymizer from Presidio. Obviously, I will evaluate this later, but I didn't label that data since I just generated it. But you should. And yeah, it's you do some entity mapping, but essentially, like all of this, I made it so I could choose like a stanza, spacey, or hugging face transformer. Yeah, it's a really short script. So you can see I'm on a CPU, so this is going to be a little slow, but it's using the like a Stanford Hugging Face NER model to anonymize that text I showed you earlier. Really, it only takes a few seconds, but we can switch over to the text I anonymized already. So here's for instance, we have a doctor's name and the organization's name, the patient's name, etc. So what Presidio does is it just replaces it with the placeholder, and you can customize those too, and like customize it as much as you wish. Anyway, so that's Presidio, and it has like 147 contributors already. So if you want to contribute, I mean, it's completely open source. And yeah, quick plug, there's a meetup coming up in January. I'm also an organizer, so please attend. It's online, so for those out of town, you can come to this as well. So thanks.
Good afternoon, everyone. I don't have a laptop, but I do have a desire and a wish and a personal project that I am working on. According to the March of Dimes, pre-birth rates of race and ethnicity in 21 and 23, 14.7% blacks had premature babies. Native Americans, 12.4%. Hispanic, 10.1%, whites, 9.5%, and Asian and Pacific Islander, 9.3%. Some of the factors they address could be socioeconomic factors, stress from racism, health conditions. I was a product of a premature baby. I had 2 babies who were premature, and I had a daughter who had a premature baby, and one passed. This is a problem. This is a national problem. And until we put it into our objective that every child deserves to start off at the finish line the same, then we will not be the healthy nation that we want to be. My goal, my desire of what I'm working on is using AI and machine learning to find a way to predict high-risk women who are high risk in their pregnancy, to reduce premature labor. Not only the desire, it is one of my objectives. To be affected by this and to help your newborn and you're there all the time, you don't know where she's coming or going. I do not wish that on my worst enemy. So I love AI, I love data, because it tells me that we can do better. It gives me history, it gives me pattern, and it gives me a way of finding the cause to this crazy, crazy statistics. Thank you very much.
Hello, everyone. I also don't have my laptop with me, so I'm just going to be talking long. Thank you for that talk. That was very inspiring. So I want to talk to you about an opportunity if you are an industry professional to network and help university students. And if you're a university student, to be able to network with other students and to possibly connect up with industry professionals. So I'm actually a career changer, and I decided to go back to school and kind of do things right, because when I went through my bachelor's degree, I didn't really get that involved in the community. But when I went back to school, I'm getting my master's in computer science at the University of Washington, Bothell, and I decided to get as involved as I could in the community there. And so I joined the ACM, the Association for Computing Machinery chapter at UW Bothell, and we host a lot of events throughout the year. They're all open to the public, and most of them are career focused. And we also have like little things like job hunting groups where if you're looking for a job, you can join and get like one-on-one help. And we host a hackathon contest at the end of the year in April. And last year we invited hundreds of industry professionals to our campus as mentors, judges, and guest speakers. And we're also always looking for sponsors for our events. Like you could chip in a little bit for our lunch or something like that. But it's just a way to connect up with other people and get involved. So I'll point you to our website. It's uwbacm.org. And I'm happy to chat with you at any time. Our hackathon is called UW Hacks. And this coming April will be the 10th anniversary of this hackathon. So we're hoping it's going to be really huge in the area, and really super excited about it this year. Thank you.
Okay, hi. I honestly put the slide deck together in between the fourth and the fifth speakers. So, okay, so I'm going to talk with you about data architecture and informatics maturity. So, I'm an assistant professor at University of Washington in the biomedical informatics and medical education department. I'm also the chair for the American Medical Informatics Association Informatics Maturity Working Group. And so some of that is to think about, like, if we build a tool, how do people use it, adopt it, and then it becomes system-wide? And it actually feels like they're more apt towards like future tools. I'm going to put this slide up here first, and then I'm going to end on it as well. But my call to action to you all is to sort of think about the learning curve with some of the tools you're building. This is definitely into the user experience side of things. But I also kind of want you to think about if your tools are meant for a general audience or if there's like specific niche audiences. I'm in the medical field and public health field, so I think there's definitely some specific use cases that I think some folks may not know about. So if the fourth item on here, come chat with me, and then I'd be happy to just chat back. One of the items that I tend to work on as an assistant professor is on several biomedical informatics projects that are multi-hospital site, multi-academic institution, and oftentimes sometimes it's even multinational. So the sort of policy and data transfer, data sharing agreements is all over the place. Those things take place before we can even do any research. So with that, the data architecture and data sharing conversation is usually something we have to talk about with regards to our research, with regards to how long we plan to have this program going. And so these four types of architecture are usually the ones that we will generally talk about and come to agreement. Do we ever need our data all pooled in one place? And if so, how big is this going to get? Do we need to have a huge server pool? Or do we need, can we get a cloud platform in order to service certain bespoke projects? Other times, the federated query approach is actually something that's growing more and more. And model to data is another approach to it. If anybody here is familiar with Sage Bionetworks, it's sort of like every health institution keeps or maintains their data in a certain place. People who are participating in data challenges generate models, and then there's a competitive development, but they never actually get access to the data themselves. So that thereby allows like a competitive access to data and model training, but ultimately it helps this sort of crowdsourcing and citizen science approach towards biomedical research innovation. This slide is from actually a paper published in 2011, but I feel like a lot of these use cases still hold true. My area of research happens to be more in emergency and disaster preparedness, and those are like the top 2 to 3 items up on this public health use case list. And if you want the slide deck, I'd be happy to share it as well. But many of these other items usually go into the area where it's patient care, and there's PII and PHI involved. So usually in those areas, people are very conservative, or health institutions are usually very conservative about sharing that type of data. But in terms of research data sharing, I helped co-author the research data sharing maturity model, which we published this like 3 years ago, but the landscape of new tools and the landscape of data policy and what is allowed to be shared has constantly changed in the last few years. So we haven't really seen anybody like apply this just yet, but I'm looking for ways to do so. We did author a 10 simple rules paper for advocating to health institutions and academic institutions. What do they need to do in order to be able to do research data sharing? And I think some of this also gets into the area of like adopting new tools. How do I use these tools, apply it to my data, or apply it to a health system's data that's continually growing every day? Here's a little bit of bad news. So 2 years ago, there was also there was a report on public health and the informatics capacities within the public health systems. So this is county, state, and national, it's usually local and state public health systems. Most people are epidemiologists. They're not trained in software development, or they might be trained in statistics, but once you're getting into certain tools that require a completely different set of interactions, it's a different person that you're having adopt your tools. But the informatics capacities, often it's very large, high population areas that have enough resources to train their staff. Some public health institutions are really understaffed, and they just don't have the skills or the time to do while they're also applying to protect public health. I have also co-authored not co-authored. I am the author for a Python library called Observational Gridded Hydrometeorology. It's a it's a Python library originally to help bring in widespread geographic data sets so that I could do research with medical data. This is something I'm hoping to continue, but there are multiple issues with trying to pull that amount of data into an environment with small patient pool or regionally specific patients. So if any of this resonates with you, my call to action is think about public health, think about the people who would be trying to adopt your tools, and I'd be happy to come chat.